This is a tutorial on how to find a missing side when given two similar triangles. Now when you're given two similar triangles, there's two important pieces of information that you know. One is that corresponding angles are congruent. I have a little arc here and a little arc here indicating that these two are corresponding angles and that they are congruent. I also know that these two angles here are congruent because I have these two little arcs here. And I know that these two angles here are congruent because this little box indicates that this angle here is 90 degrees. Both of them are 90 degrees, so these two angles must be congruent. The second thing I know is that for triangles that are similar, they are proportionally the same. That means for whatever multiplier took this 3 to the 9, it will also take the 4 to question mark and the 5 to the 15. So we're trying to think of some scale factor that will take us from one side to the next. So I'm going to write a proportional equation. And the way that I write a proportional equation is I need to think of it as an analogy. Like in language arts when your teacher says, for example, the Alaskan tundra is too cold as say the African desert is too, and the answer in this case would be too hot. So we're trying to think of what is to what as what is to what. Well, 4, in this case, we could start anywhere, but I'm going to start with the 4. 4 is to question mark, so I'm going to go from the smaller triangle to the larger triangle. So height is to height as base is to base, as base is to base. It is also true that this hypotenuse, opposite the 90 degree, this hypotenuse is to this hypotenuse, so 5 is to 15. Now, I drew this arrow because I just want to make sure that I'm consistent. If I'm starting at one side, when I start with the smaller triangle and then I go to the larger triangle, I need to be consistent with the other proportions. So if you were to simplify this 3/9, you're going to get 1/3, and if you simplify the 5/15, you're going to get 1/3 as well. And so I'm trying to think of some value, some number for a question mark that will give me 4 over question mark, that will give me 1/3 as well. So I have this 4 over question mark, and that equals 3 over 9. And then I'm going to multiply both sides by question mark, because question mark divided by question mark is 1. That gives me 4 equals 1/3 question mark. I'm going to then multiply by 3 to both sides, because 3 divided by 3 is 1. And that gives me that I have 1 question mark on the right-hand side, and then I have 12 on the other side. Now we could also do something called cross multiplication. Cross multiplication, where if I have this 4 over question mark equals 3 over 9, I cross multiply, I multiply crossways or diagonally. That gives me 3 times question mark, and that equals, I multiply crossways the other way or diagonally. That gives me 4 times 9. And 4 times 9, that's going to give me 36. And 3 times question mark, well, this is times, so the inverse of multiplication is division, so I'm going to divide by 3. That gives me that question mark equals 12. I get the same answer. Now I want to caution you that the only time you're ever going to use cross multiplication is when you have a fraction equals a fraction. In some classes I have students that when you see something like this where I have x over 3 plus x equals, let's do divided by 3 over x minus 1, that they'll try to do some form of cross multiplication. Or if I had, 1 over x times 3 minus x over 2, then they're going to try to use some form of cross multiplication. The only time you ever use cross multiplication is when you have a fraction equals another fraction. So let's move on. Oh, one other thing I wanted to point out for this particular problem is we could have set up other ratios. Like I could have said, for example, 4 is to 3, so height is to base as height is to base. Height is to base. So there's other ways we can set up the same problem. We just need to make sure that it's logical. Otherwise, there's many other ways we can set this up where it's not true. So let's move on to this one. I have parallel lines cut by, let's look at this transversal. And one of the parallel postulates says that if we have parallel lines cut by a transversal, that these two angles right here, they are congruent based upon alternate interior angles. So this angle is congruent to this angle. We also, if we look at this transversal cutting the parallel lines, then these two angles are going to be congruent based upon the same thing, alternate interior angles. So I'm going to indicate that with two little arcs for both of those angles. Now these two angles here, they are also going to be congruent based upon vertical angles, so I'll just use, I guess, 3 arcs to show that those are also congruent angles. So I'm going to set up a proportional statement. I'm going to say that the smallest side, I'm going to move from the smaller triangle to the larger triangle. So smallest is to smallest, smallest is to smallest as, well, I don't know what this is. Second smallest is to second smallest. Second smallest is to second smallest. Now you can see for both of these fractions, I moved from top to down, equals top to down. So smallest is to smallest as second smallest is to second smallest. Now this is not a 9, it's an A. And so I'm just going to use cross multiplication. Multiply this way, I have 5 times A, and then multiply this way. 7.5 times 2 is going to give me 15. I have 5 times A, the inverse of multiplication is division. I'm going to divide by 5. That gives me that A equals 3. All right, for this problem here, our smallest angle, it looks like, is C and Z. So we've already used 1 arc, so I'm going to use 2 arcs here. And then that means that our third angle, we can indicate that with 3 arcs. Now this one looks a little bit more difficult because it looks like a rotation and possibly a reflection happened. So we need to be a little bit more careful when we set up the proportional relationship here. So I'm going to go from, let's go from 1 arc to 3 arcs, 1 arc to 3 arcs, and that would be the corresponding angle is going to be here, or corresponding side, I apologize. The corresponding side is going to be here, 1 arc to 3 arcs. So I can say that 10 is to 15, 10 is to 15 as, well, let's find the corresponding side to the A. This is 2 arcs to 3 arcs. So 2 arcs to 3 arcs would be here, so that would be from 14 to A, 14 to A. So we're moving in both directions, which is pretty important, otherwise we're going to set up an equation that's actually not true. So we have 10 is to 15 as 14 is to A. So we're going to use cross multiplication. We're going to multiply this way. I have 15 times 14, and that equals 10 times A. Well, 15 times 14, 15 times 14 is going to give me 210. So I have 210 equals 10 times A. Inverse of multiplication is division, so I'm going to divide by 10. That gives me 21 equals A. 21 inches, feet, I don't know. There's no units that are given here. So number 4, if this is 2 arcs, 3 arcs, 2 arcs, 3 arcs, this must be our single arc. And let's set up an equation which involves x. So this is small side to medium side. So we're going to go from here to here. I don't care which way you go as long as you're consistent. So 4 is to x as 6 is to 7. So short is to second long as short is to second long. Now I'm going to cross multiply. I'm going to multiply this way. 4 times 7, that's going to give me 28. And that equals 6 times x, which is 6x. I'm going to divide by 6 to both sides. 6 goes into 28 4 times. 4 times 6 is 24. 28 minus 24 is going to give us 4. We can bring down a 0. 6 goes into 40 6 times, sorry, I was way off. 6 times 6 is 36. And then 40 minus 36 is going to give me 4. I can keep on bringing down zeros, and I'm going to get 6, 6, 6, 6, 6, 6, 6. It's just going to keep on going on. So we have this x equals 4.6 bar. Now y, y, it looks like y is something, it looks sort of like a hypotenuse. I don't know if it's the hypotenuse, but it doesn't really matter. It's just a matter of setting up an equation. So if I have, so I'm going to have short is to hypotenuse. Well, let's be consistent. Let's go, I said from right to left. So short side is to hypotenuse, as short side is to hypotenuse. 6 is to 8. Short side is to hypotenuse, as short side is to hypotenuse. So I'm going to cross multiply again. 4 times 8 is going to give me, I'll just write down 4 times 8 equals 6 times y. 4 times 8 is 32. That equals 6y. I'm going to divide both sides by 6. 6 goes into 32 5 times. 5 times 6 is 30. 32 minus 30 is going to give me 2. Bring down 0. 6 goes into 20 3 times. 3 times 6 is 18. We bring down another 2. So we see that we just keep on getting these 20s that repeat themselves. So this becomes, our y is 5.3. So I end up with x equals 4.6 bar and y equals 5.3 bar. These are my answers. If I knew what the units were, I would indicate that as well. All right, so moving on. Number 5. We have 2 triangles here. I have this smaller triangle here, but I also have this larger triangle here. And they are similar because, well, I have this angle in common. These 2 angles here, this angle and this angle, if these are parallel lines, these would be corresponding angles. And so they are congruent. And then that means that the last one, that those angles have to be congruent as well. So my proportional equation is going to be 15 is to 7 as 15 plus x is to 11. Then we're going to use our cross multiplication. 15 times 11 equals 7 times 15 plus x. 15 times 11, 5, 1, 5, 1. That's going to give me 165. So I have 165 here. That equals 15, 7. I'm just going to, we get 105 plus 7x. I'm going to subtract the 105 from both sides. That's going to give me 60 equals 7x. So, well, how many times does 7? I'm going to divide both sides by 7 to get x by itself. And how many times does 6 go into 60? I don't know. It's maybe 9 times. That would give me, nope, it would be 8. 8 times 7 is 56. And then 60 minus 56 is going to give me 4. We can bring down the 0, and 7 goes into 40. That goes in, 7 times 7 is 49, so 6. 42, 5 must be 5. So 7 times 5, that's 35. Subtract, that gives us another 5. Bring down the 0. And 7 goes into 50. It looks like it's deteriorating. We'll just do one more. 7 goes into 50. It would have to go in 7 times, because 7 times 7 is 49. And that gives us 1. So there you go. We're getting that x equals 8.57 units. Right. The next one, I think this is a cool idea. I have a palm tree. I don't know how tall it is, but if I know my height of 5 feet, and I know my shadow, the length of my shadow, and I know the length of the palm tree, I can figure out what the height of the palm tree is. So my height over shadow, so height over shadow is to height over shadow. Height over shadow is to height over shadow. I messed up. Height is to shadow as height. This is not 5, it's x. X. So I have x is to shadow. So we're going to cross multiply again. I'm going to multiply this way. That gives me 5 times 26, and that equals 6.5 times x. And 26 times 5, that's going to give me that gives me 130 equals 6.5x. And then 6.5 goes into 130 20 times. So I get 20 feet. The height of the palm tree is 20 feet. So let's look at the last one. This is also a cool idea. If I have a mirror and I place the mirror in such a way that if I look through the mirror, I'm standing erect, and if I look through the mirror, I can see the top of the building, then these two angles here are congruent. And if the building is perpendicular to the ground and I'm standing perpendicular to the ground, then I have similar triangles. So distance to the mirror is to height as distance to the mirror is to height. Distance to the mirror to height is to distance to the mirror to the height. And I'm trying to figure out what x is, so I cross multiply again. 6 times 32 equals 2 times x, and 32 times 6 is going to give me 192. Then I divide by 2, that's going to give me, that 2 goes into 192, 96 times, so we have 96 feet. The height of the building is 96 feet. Hope that was helpful, and have a wonderful day.